wake up in your bed, but it feels different. It's softer than usual. You stick your finger into it, but instead of poking something hard and springy, your finger goes right through. Your entire body starts to sink, slowly at first, then faster and faster until you completely vanish into the bed. What happened? How is this possible? Your bed has turned into a black hole. But what if the entire planet turned into a gigantic black hole? That's not possible, right? I mean, we'd have to find a way to make a region of space infinitely dense. Well, maybe not. Scientists recently figured out how to turn Earth into jelly. And while it won't literally turn our planet into jello, they found a clever way to describe Earth's gravity with the properties of a specific kind of jelly. So let's take a closer look at this jiggly solution to gravity. Jelly is one of those things that everyone loves, unless you hate jelly. But even if you don't like it, you probably know what it is. Jelly is basically a liquid that got trapped inside a lattice of other molecules that couldn't move around freely. In most common gelatin desserts, the liquid is water and the lattice is made of protein molecules. The water gets trapped when the protein molecules solidify in a particular shape. That means no matter how much the water molecules move around, they can only go side to side or up and down. They can't escape the rigid structure. This is called a gel. It sounds pretty simple, but scientists actually haven't been able to create a gel in a lab since 1976. That is because all of the gels they made fell apart before they could study them. That changed in 2023 when a group of physicists managed to produce a stable gel for the first time in almost 50 years. They did this by cooling a liquid made of molecules called rubidium and strontium below their critical temperature. At low enough temperatures, these atoms would normally form a regular crystal lattice, but that doesn't happen here. Instead, they form an exotic state of matter called a supersolid, which is also a gel. But why are scientists so interested in making gels? It's because gels have a lot more in common with black holes than you might think. Black holes are regions in space where gravity is so strong nothing can get out, not even light. Their gravity warps the fabric of space-time itself. Because they're so dense, they have an extremely powerful gravitational pull. And the boundary between a black hole and the rest of the universe is called the event horizon. Once something crosses the event horizon, there's no turning back. Not even light can escape a black hole's gravity. And this may sound pretty different from a block of wobbly strawberry dessert, but the mathematics of how stuff falls into a black hole is exactly the same as how molecules fall into a gel. In both cases, you've got some sort of lattice that prevents things from moving through it freely. For black holes, it's the distorted fabric of space-time. For a gel, it's the frozen molecules. In both cases, though, once you cross the boundary, you can never return. And here's where it gets really interesting. Physicists believe that our entire universe could be described as a gigantic gel, except instead of being made of protein molecules, it's made of quantum foam. This quantum foam is a type of background radiation. It's all around us and it's incredibly tiny. We can't detect it with current technology, but we do have evidence for its existence from things like the cosmic microwave background. So if our universe is a giant gel, does that mean Earth is a giant piece of toast? No, not quite. Unlike a piece of toast, Earth still has a surface. It just has a weird gravitational pull. But the thing is, A real black hole would have an event horizon, a clear boundary where its gravitational pull becomes inescapable. But Earth doesn't have a clearly defined boundary. The further away from Earth you get, the weaker its gravitational pull becomes, but it never drops to zero. Even if you were 240 million kilometers away, which is the average distance from the Sun to Earth, you'd still feel a tiny tug from our planet's gravity. To describe this, physicists need to figure out how to calculate the gravitational pull of a planet like Earth that has a noticeable gravitational pull at a great distance, but not as strong as a black hole. And the problem is they couldn't figure out any formula to describe this until recently. That's why creating a gel in the lab was such a big deal. By studying how molecules behave in the gel, physicists hope to learn how to model our entire universe. They found that the best way to describe Earth's gravity is by assuming that our planet isn't a single object, but rather a cloud of molecules with an extremely complicated gravitational field. But they can use their new gel experiments to figure out how to mathematically describe this complicated field. If they can do this, they'll have a better understanding of how galaxies form and fly past each other. They'll also better understand the early days of the universe when it was hot and dense. Like, imagine you are trying to pin down exactly how fast the universe was expanding 13 billion years ago. It's very difficult because the universe isn't exactly the same today as it was back then. It's expanded and cooled, which makes it hard to extrapolate backwards. But if scientists can better understand how gravity works, they can use that knowledge to better study our ever-expanding universe. But what if we want to turn Earth into actual Jello? To do this, we either need to somehow turn off the repulsive force that keeps matter from getting too close to each other. You see, we're all familiar with the attractive force of gravity, but there's another force that acts between all particles. It's called the strong nuclear force, and this force is what holds protons and neutrons together in the nucleus of an atom. The thing is, this force is really strong, but it only works over extremely short distances. As soon as you get a few atomic nuclei apart, the strong force becomes negligible. So to turn Earth into jelly, we'd have to get all of the atoms really close to each other. And if we could do that, the gravitational attraction between all of the atoms would keep them stuck together. But unfortunately, we can't do that. We'd have to overcome the electron shell. To get all of the atoms close enough to each other to form a gel, we'd have to force the negatively charged electrons to get extremely close to each other. And we can't do that without overcoming the electromagnetic force that pushes them apart. And that force is way stronger than gravity. So Earth won't be turning into jelly anytime soon. But now that scientists have created this new type of gel in the lab, who knows what they'll discover next? Maybe one day they'll even figure out how to make a real-life teleportation device. Then we can teleport our cars to work and never have to deal with traffic again. Just imagine the possibilities. You could eat a slice of pizza in New York and then poof, appear in Paris seconds later. But first, you'd have to find a way to teleport the 12 pounds of pizza in your stomach. Check out this video to find out how that's possible. Or check out this video. It's up to you. Click on one of these things. I don't know.